All right, so in this video, we're going to talk about polyatomic ions. Okay. Now, when it comes to polyatomic ions, all right, let's kind of break down that word polyatomic. Poly means more than one, right, or many. So this is an ion that consists of many atoms or more than one atoms. And in a sense, it's a compound that has a charge. All right, really. And so I know usually when we talk about monoatomic ions, this is a just a single element or single atom that has a charge. It's a charged atom. In this case, a polyatomic ion is basically a charged compound. All right, so compounds are usually two or more atoms or are chemically bonded, right? But in this case, they're not neutral, but they have a charge. All right, and so polyatomic ions, I mean, they're all over the place. You know, a lot of compounds that we deal with on a daily basis consist of a polyatomic ion. Okay. And so since we're going to talk about this so frequently in class, it is going to be mandatory, I would say, to have these to have the names and the formulas memorized. Okay, and I'm going to talk about in this video at least the ones that I will require for you guys to memorize for in class. Okay, so let's jump into this. And so we have first example, we have H3O plus. All right, so this one is called hydronium. All right, so this is the hydronium ion. Then we have NH4 plus. This is called the ammonium ion. All right, so these are the only two polyatomic ions that have a positive charge that we're going to talk about. Most of the polyatomic ions are all going to have negative charge, the ones that we're going to talk about in class, but these are the only two that's going to have a positive charge. Okay, so I think these two are somewhat easy to remember ish. All right, anyways, so we have CH3CO2 negative. This is the acetate ion. Okay, then we have CO3 negative 2. This is, or 2 negative, sorry. It is the carbonate ion. Okay. Then we have HCO3 negative, so a little bit different from the one above it. This typically have two names. Sometimes you would see it's called the hydrogen carbonate ion, or sometimes it's called bicarbonate. Okay. Then we have CrO4 2 negative. This is the chromate ion, and do not get this confused with the Cr2O7 2 negative. This right here is what we call the dichromate ion. All right, so two different types of polyatomics. All right, continue going on with the list. Then we have Cn. This is your cyanide ion. Yep, cyanide. All right, then you have OH negative. This is what we call the hydroxide ion. So hydrogen and oxygen bonded together. Okay. All right, now the next one here we have ClO negative. This right here is what we call the hypochlorite ion. Okay. Then the next one we have the NO3 negative, which is the nitrate ion. Do not confuse nitrate with NO2 negative, which is the nitrite ion. So the difference of one letter. All right. Then you have C2O4 2 negative. This is oxalate, your oxalate ion. Then we have MnO4 negative. This is the permanganate ion. That's supposed to be N here. Permanganate. Okay. Then we have PO4 3 negative. This right here is your phosphate ion, which you should not confuse with HPO4 2 negative, which this is your hydrogen, hydrogen phosphate ion. Sometimes they call this the biphosphate ion. Okay, which you should not further confuse with the H2PO4 negative, which this is called the dihydrogen phosphate ion. Okay, then you have SO4 2 negative. This is your sulfate ion, which you should not confuse with your SO3 negative 2. This is what we call the sulfite ion, difference of one letter. Okay, and hopefully you will not also confuse the HSO4 negative, which this one is called the hydrogen sulfate ion, or sometimes this is called the bisulfate ion. So this is just the list of polyatomics. I probably should have done this in columns, right? Polyatomics that you definitely need to have memorized in class, because it's good to know them. Okay, so there you go, polyatomics.